What's up guys, it's me Sir Ernest, and today we're going to talk about acceleration in plane polar coordinates. Now let's recall the position of a particle in plane polar coordinates is equal to r hat. The velocity on the other hand is equal to r dot r hat plus r theta dot theta hat. Okay, also, we talked about in the previous video how the radial unit vector r hat changes with time. And we found out that this is equal to theta dot theta hat. Okay, now before we talk about acceleration, let's talk about first how theta hat changes with time. So we know that theta hat is equal to negative sine theta I hat plus cosine j hat. And taking the derivative of this becomes negative cosine theta theta dot I hat minus sine theta theta dot j hat. So we can factor out negative theta dot. So this becomes negative theta dot times cosine theta I hat minus sine theta j hat, or plus sine theta j hat. And cosine theta, as we learned already, cosine theta I hat plus sine theta j hat is r hat. So this is now equal to negative theta dot r hat. And we're going to use this together with this to calculate the acceleration of your particle in plane polar coordinates. Now the acceleration is just the derivative of the velocity with respect to time. So we just take the derivative of this. So this is derivative of r dot r hat plus r theta dot theta hat. And this is equal to r double dot r hat plus r dot derivative of r hat with respect to time. So this is for the first term. The second term, because it has three variables and all of them are theta dot and theta hat, all are functions of time, therefore using product rule this will have three terms. So the first term becomes derivative of the first, and then we copy the rest. So this is r dot theta hat, and then we differentiate the second and then copy the rest. So this is r theta double dot theta hat, and then we differentiate the last, copy the first two. So this is plus r theta hat dot derivative of theta hat with respect to time. So we already know derivative of r hat with respect to time and derivative of theta hat with respect to time. So copying everything together, we now have r double dot r hat plus r dot theta hat plus r dot theta hat plus r theta double dot r hat minus r theta squared r hat. So you will notice that we can combine these two and then group it with this term because they are all in the theta direction. And then we combine this and this because they are both in the r direction. So therefore, the final form of your acceleration in plane polar coordinates is now given by r double dot minus r theta dot squared r hat plus r theta double dot plus 2 r dot theta hat. So here the radial component and the transverse component are given by these two. So AR, the radial component, will be r double dot minus r theta dot squared. And then the transverse component would be r a theta, and this is equal to r double dot plus 2 r dot theta dot. Okay, so that's it. That's your acceleration in plane polar coordinate system. Okay, so in the next video we're going to check if this is consistent to uniform circular motion. So thank you guys for watching, and I'll see you guys in the next video. Bye bye.